Hi, in this video we'll be looking at how to find the domain of a function. The domain of a function. So, as usual, let's look at some couple of examples. It says find the domain of the following functions. Now the very first function we'll be looking at is f of x equals 2x divided by x squared negative 4. Now actually looking at this function itself, it's written in a rational form. And then you recall that whenever you have any rational expression, say of the format 3 divided by 0, we would say this is it's undefined. So that is to say, anytime you're given a rational expression, you need to exclude all numbers that would set the denominator to be 0. Aside other numbers, then every other number makes the function to be defined. So that is to say, the domain of the function is going to be the set of all real numbers excluding those set of numbers that would make the denominator to be 0. So in other words, the domain is going to be the set of all real numbers such that x squared minus 4 does not equal to 0. Now, if you want to solve x squared minus 4 equals 0. I want to find the numbers that is going to make this to be 0. Now to solve this, you observe this is x squared minus 2 squared equals 0. So this difference of two squares, which we've talked about in the previous videos, that this is going to be the x minus 2, the difference times the sum, x plus 2 equals 0. And then when you multiply two things and you have 0, it implies that one of them must be 0. Either this is 0 or x plus 2 equals 0, and then this equals 2 or x equals negative 2. So that is to say, this number and this number are the two numbers which, when substituted into the function, would make the denominator to be 0. So therefore, my domain could also be written as x such that x does not equal to 2 and x does not equal to negative 2. Now this is it in set notation. So if I want to write another notation, now you recall in your number line that you have something like this. So this is another way of writing it. So let's say this is my number line. Let me draw that again. Let me make it a finer picture. Yes, this is much better. Now in my number line, the point negative 2 should be probably somewhere here. Let's say this is negative 2, and then let's assume this is 2. Now to draw the number line, I have to I'm excluding negative 2, and I'm also excluding 2. So every other number, say from here to here, all numbers between negative 2 and 2, they are included or they are valid for this function. Also, all numbers from here to here down to positive infinity, they are also included. And then similarly, all numbers from here to here are also included. That is from negative 2 to this. So if I want to write this down, this is going to be, so since it goes to negative infinity, this will be negative infinity, you close the bracket, comma, then negative 2. Now since negative 2 is not included, I'm going to use this bracket. But assuming negative 2 was included, I would have used the square bracket. But since negative 2 is not included, I'm going to use this bracket here. And then it also goes from negative 2 to 2. So you write negative 2 to, it stops at 2. Now 2 is not included, so I use this bracket here. And then finally, we also move from 2, then it goes to infinity. So it goes to infinity. So therefore, the domain which we've written here, that is the domain. So this is a way of writing the domain. This is another way of writing the domain. The domain is just going to be the union of negative infinity, negative 2. Now union. So let's use the union. What we have here is negative 2, 2, union, and the last one, which is 2, infinity. So this is another way of writing in the domain of the function. So I just decided to use all this just to demonstrate and to make it clearer to you in terms of the analysis. So let's look at one more example just to ground understanding. So example 2. So we want to find the domain of this new function. Let's call the function g of x equals 4 divided by the root of x minus 9. So we want to find the domain of the function. Now you'll observe again that this function here is a rational function, and all rational functions are defined except the values of the rational function for which the function itself equals 0. So that is to say, the domain of this function is going to be the set of all real numbers excluding the numbers that would make the denominator to be 0. And then not just 0, because you observe this is a root sign here. Now since this is a root sign here, every number in this root sign must be greater than 0. So the domain is going to be all numbers such that x minus 9 is greater than 0. There are two conditions which you need to satisfy here. The first condition is that for the fact that it is x minus 9, since you know that a negative or the root of a negative number is going to be a complex number, so what we want here should be x minus 9 must be greater than or equal to 0. But then the equality sign here is a plus. That is, it's plausible in the sense that when x minus 9 equals 0, the denominator here becomes 0. So the real domain should be a set of all numbers such that x minus 9 is greater than 0. We need to exclude all numbers that are going to make the function value of the function itself to be undefined. So this is the domain. So which is the same thing as x such that x, so when you bring negative 9 to the side here, so you have x greater than 9. Or another way of writing that is by, if I show you this, you have something like this, just like we did over there. So we have, maybe here is our 9, and then if you want to draw this, say this point here, so it says x greater than 9, just the greater than 9, so it goes in this way here. So since 9 is not inclusive, so we'd say 9, and then it goes infinitely, so we'd write infinity. So this is also written as or 9 infinity. So this is the domain. You could either say this or this is the domain. Either of them works fine. Thank you.